Welcome to Cisco Tech Beat, the podcast that explores the people and stories behind what inspires the newest innovation. I'm your host, AB, and today I'm thrilled to welcome Matt MacPherson, Chief Technology Officer, Cisco Wireless. Matt's group has worldwide responsibility for Cisco's wireless thought leadership through analyzing technology and industry trends and providing direction to product and engineering teams. Matt, welcome to Tech Beat.
Hey, it's really great to be here and looking forward to the discussion.
Me too. And of course, a lot of our discussion today is going to focus around the future of wireless convergence and Wi-Fi and cellular, the impact of Wi-Fi 7 on reliability, resiliency, and speed, of course. So I want to start with some basics here. What is wireless convergence, and why is it important? And what are the challenges in achieving seamless roaming between Wi-Fi and cellular networks?
So, great question. You hear a lot about convergence, and I think that means different things to different people. When I talk about convergence, sometimes we talk about it in the context of spectrum. What are we doing with the different pieces of spectrum, and how can we run different stacks in it? We talk about convergence in architecture. So, in fact, if you look at 5G architecture and if you look at Wi-Fi architecture, we're seeing some real similarities starting to come forth. But when we talk about access and we're talking about wireless, what we really mean about convergence is how do we take these dominant stacks that we all use every day? How do we take that 5G connection that if you looked at your phone, you're probably connected to right now? How do you take that Wi-Fi connection and how do you use those to the best benefit? In fact, if we do this right, convergence should make this completely transparent. When we talk to most users, they really don't care if they're going into Wi-Fi, if they're going into 5G, as long as they can access their services, they can do it in a secure way, and they can get a good experience. So when we talk about convergence, especially around access, we're talking about tying some of these different types of technologies together to a unified experience.
It seems like it wasn't that long ago when we were introduced to Wi-Fi 6 and then, of course, Wi-Fi 6E. We're already at Wi-Fi 7, which seems really quick, right? So what are some of the advancements that Wi-Fi 7 brings when compared to previous Wi-Fi generations, including 6 and 6E? And how does that improve speed, reliability, and resiliency to enhance the end user experience?
So, why don't we step back for a second? I'll take you on a little bit of a journey. You can see I've got a few gray hairs in my beard, so I've been doing this for a while. And so, I remember when Wi-Fi first came out. When Wi-Fi first came out, it was a convenience. I thought Wi-Fi was cool because I could go out on my back deck and I could read my email from my laptop. That's all I was really looking for.
Right.
But that Wi-Fi and that simplicity is gone. Where we are now is where the stacks have really moved along. We have much more capability. We have this deterministic nature of the connectivity that means that we can have some control over things like latency and jitter, as well as the higher speed bandwidth that everybody expects in the next generation. So if you look at this, if you step back a little bit and you look at Wi-Fi 5, and most of the world is still using Wi-Fi 5. Now we're selling more Wi-Fi 6 than anything else, and 6E is starting to ramp up and actually pass Wi-Fi 6. And of course, 7 is coming out right around the corner. But everybody's used to Wi-Fi 5, and it's got a little bit of a stigma because what happened is we filled up the 2.4 megahertz, and then we added more spectrum in 5 gigahertz. And then what did we do? We filled that up too. So this technology has been, I would say, more successful than anybody anticipated in the beginning. And so if you look at Wi-Fi 5, it's really a technology that is something that you try to, from a management perspective, over provision it and under-subscribe it. And if you're starting to see more demand than you provision, then what do? You go in, you re-engineer it, maybe you put in more APs, maybe you add more spectrum that you have access to, you upgrade devices, and so you just always try to stay ahead of that curve. Now in Wi-Fi 6, we made a really big change. We enabled not only OFDM, which is what all the legacy technology, at least many of the recent versions, are based on. And we went to the capability to do OFDMA. What does that mean? I'm not going to get into all the acronyms and technology and everything, but what it basically means is that you can now transmit not only in time, but you can subdivide your transmissions into the frequency domain. That means multiple devices can be talking at the same time. Now, in last generation Wi-Fi, you couldn't do that. You'd have one device that was talking. The other devices, if they needed to talk, they listened. And when the air went clear, they would vie for that air interface. And if two things started talking at the same time, what would happen? It would collide. And when you get that collision, they would back off. Now, you don't want them both trying to retransmit again at the same time. So they back off a random amount. One gets on, the other waits. And so it's a very polite protocol. The problem is everything that we do today is high density. We got IoT going on the networks. Everybody's carrying multiple devices. And as you increase that number of devices and they're all vying for that air interface, you get this boom, 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 especially as utilization goes up. Now it becomes unpredictable, right? You don't know what kind of latency you're going to get for those packets. At the best case, if the air is clear, you can get milliseconds. Worst case, it could actually turn into seconds. And so what's happened is that Wi-Fi has been then dubbed kind of a best effort technology. Well, the industry saw the next generation applications and services coming, and so they wanted to address this. And that's why we started doing this frequency division. If multiple devices are talking at the same time, you know what they're not doing? They're not colliding. Right. So this really protects against that collision domain, that unpredictable latency characteristic. Now, there's two things that you really need to do to get to a deterministic behavior, or let's call it predictable behavior. I mean, what does IT really want? They want to be able to predict what kind of experience they're providing to their users, because a good experience means high productivity. A bad experience means low productivity. We're all dependent on this wireless network. We use it every day. And so we have to make sure that we can control that from an IT perspective. Two things you have to do. One is you have to have a stack that you can schedule. So a stack that can prioritize and schedule based on the needs for the different devices. And two, you need to be able to protect against interference. It doesn't matter how intelligent your stack is. It doesn't matter if it's Wi-Fi 5, 6, or 7. If you're getting broadsided constantly by other radio use, it's unlicensed. Remember, other things can use the radio. If you keep getting broadsided by other frequency use, then what happens is you get high error rates and you end up retransmitting anyway. So that's sort of the progression that we've made. In 6, we added the capability to schedule from the network. We added the capability to do frequency division. Those are stack capabilities. But we could still have a problem with interference. In comes 6E. And what do we have? 1,200 more megahertz that we can use so that we can find clean spectrum where we're not getting broadsided by these other uses. So what does 7 do? 7 takes it to the next level. It really raises the bar from a security standpoint. It allows you to do simultaneous connectivity. It's called MLO, or multi-link operation. Sometimes you see it as MLD, multi-link device. They're the same thing. One just means the capability in the device, one means the capability in the network. But if you can communicate over two channels simultaneously, then you can provide a very reliable, very resilient, very low latency implementation. That all produces this predictable Wi-Fi type functionality and type capability. So we're really quite excited about this. And as we demand more and more of our connectivity, especially our wireless connectivity, it's definitely going to be required for these next generation applications and densities.
Absolutely. And I love your explanation as to what the technologies were, what they are, and why it's improved. And I think ultimately, as the end user, we benefit from that and we appreciate it almost so much that we take for granted the fact that we can travel with our devices, remote regions, local regions, and really stay connected. But I want to dive into that a little bit too, because seamless roaming is something that I would love to hear your take on. But I'm curious, why is it that sometimes when we do travel, we have no issues when it comes to connecting to 5G generally, but the same can't really be said for Wi-Fi in some circumstances?
Yeah, just a comment on what you were saying in the beginning there on our expectations, because we really do just expect to connect wherever we
Yeah.
go. I mean, we really do. I mean, our phone is really a brick if you don't have that connectivity, right?
Yep.
I remember I was sitting on a plane and a mother and a little boy. I mean, this boy must have been like 4, They get on the plane and he's got a little, I don't know, it was a Game Boy or something. And the first thing he did is he looked over his shoulder and goes, "Mom, does a plane have Wi-Fi?" And so it's an expectation. I mean, even 4-year-olds are expecting to be able to connect to the internet today.
That's right.
Now, you bring up a really good point. When you go anywhere in the world, you automatically connect to 5G. Why? Because it's a B2B relationship. It's a business to business relationship. And what that means is say you have a service provider here in the US, whether that be AT&T, Verizon, T-Mobile, whoever you're connecting into, when you go over to say the UK and connect to O2 or Orange or Vodafone, they've already worked out a roaming agreement. And so what happens is that they recognize the SIM, they recognize that certificate identity that's on your device. And what they'll do is they'll connect back to your home operator and authenticate you just to make sure, yes, you're still a customer in good standing, and then automatically connect you to 5G. Now, it turns out that takes quite a bit of management. A typical company like an AT&T or Verizon, they'll have a couple hundred people actually managing roaming relationships. Do you have any idea, how many roaming relationships you need to pretty much roam anywhere in the world on a 5G network?
Not even an inkling of an idea.
Yeah, I mean, most people don't have a clue, right? So, but you know what? It's about 650. 650, just shy of 700. That's how many roaming relationships that you need to be able to do that. So when we wanted to be able to automatically connect to Wi-Fi, right, it was a little bit harder because we don't have 650 Wi-Fi guest networks running around the world. Do you know how many we crossed? In fact, it was last year we crossed 650 million Wi-Fi access networks. So, you may have heard me say this before, but you're not going to have a lawyer negotiate between 650 million different access networks for these roaming things. I mean, it's something you can do if you got 650 networks, you can't do it. So we had to be able to scale that. And in order to scale that, we had to abstract it. And what I mean by an abstraction is we built a federation, and that federation allows any access network to join, and it allows any identity provider to join so that any access network can authenticate people onto their network using any identity provider. And so that's something that we've been doing in the standards organization and a technology called OpenRoaming. So that's the first step, right? When we talk about convergence, if your device can connect to multiple different access technologies, what's the first thing you have to solve? Basic connectivity. So, what 5G has achieved, connecting anywhere, we've now achieved with a technology called OpenRoaming that's in the standards that uses Passpoint's defined by WFA, and an extension for a federated capability to connect both the identity providers and the access networks together that's done by the WBA, or the Wireless Broadband Alliance. And so we're seeing a lot of traction on that. I think there's over 3 million access networks now that's using this technology. It's quite impressive. If you walk into a venue that's using OpenRoaming, in fact, if you go to Cisco Live, you'll walk in and boom, it just connects you. In fact, the phone might be in your pocket and it'll just connect. In fact, most people are surprised. They look at their device, they think they're going to have to go to a portal or something, and boom, they're already on the network. And you know what? They love it. So that's the first step. Connect to both networks so that you can get to the second step. And so the second step is, if I'm connected to multiple networks, what path do I take? Should I go to the Wi-Fi with my data, or should I go to the 5G? And the third step is, like it, you have to take into account mobility. So right now I'm in my home, I've got a very good Wi-Fi signal, probably because I'm using Cisco APs. But I got this great Wi-Fi signal, and so it goes to Wi-Fi. Right. But if I walk out of the house, then I get a better 5G signal, and then it goes to 5G. But my phone and my devices that are capable, they're connected to both simultaneously. So that third dimension is mobility. So even though right now the best connection while I'm sitting here is Wi-Fi, it may not be Wi-Fi when I walk out the door. Right. So you have to take into account that the best connection can change.
That's amazing, and thank you for outlining the differences in how it works when you're sort of at a home base versus roaming. And Obviously there's a great argument for seamless roaming from an individual perspective because we as the end users want to have great experiences and not have hiccups when we're doing whatever we do with our devices. You mentioned B2B as part of the description as to how this technology works when you're traveling. When it comes to businesses, there's also an argument that seamless roaming drives better business outcomes, particularly when you look at industries like retail, shipping and warehousing, even healthcare. I would just love a little bit of your thought leadership on why that is.
Yeah, so this is a very vertical dependent question. And so we've talked to a lot of different verticals that offer guest networks because oftentimes when you look at Wi Fi, it's a little bit different than a cellular service. A cellular service is what we call B2C or business to consumer. So you have cellular service because you're paying the service provider for that service. When you look at Wi Fi tends to be a B2B type service. And what that means is that it's appears to be free, but obviously it's a cost center. So, for example, take a hotel. A hotel pretty much has to provide guest Wi-Fi service. In fact, I was at a Hilton convention, and I learned that the number one amenity in hotels, the number one amenity is not points. It's not the loyalty program, it's the Wi-Fi. If there's one thing that'll make a person not go back to that hotel is if they get a bad Wi-Fi experience because it directly impacts their productivity. But because it's a B2B type arrangement, the hotel sees the Wi Fi as a cost center, right? Now, you can monetize it. And oftentimes you'll go into a hotel and you'll see that there's an upcharge for a premium service. And if you want to do something like what we're doing, you're doing a WebEx or that type of thing where you really are dependent on latency and higher throughput, or even if you're just watching YouTube, right? And you want to get a good experience, you might want to pay for that premium service. So it can be monetized as well. So, some venues have to provide it. Now, in other cases, venues want to provide it because it's a net benefit to them. So let's take retail as an example. So say you go into some big retail store, right? If they attach you to the Wi-Fi, and especially if they can get you to use their application, but if they attach you to the Wi-Fi, now you are into not only the loyalty program, but you're into their multi-channel marketing, right? Which means they know because you joined that loyalty program what you're interested in. But not only that, as you're doing your shopping, it can make recommendations to you. Say you buy a printer, it might recommend, hey, do you need ink for that printer? Do you want to get the cable for that printer? Right. And so what you find in retail environments is that if you're connected to the network, it actually impacts sales. Sales can go up 20+%. So if you can move sales that significantly, they don't care what the Wi-Fi costs because it's hitting their bottom line. And if you use something like an automated connection technology, like we were just talking about Passpoint and OpenRoaming, the attach rate dramatically changes. Most venues, if they use a portal, um, don't get that good of attach rate. They get about 20-25% attach. And why is that? People hate portals. I mean, you tell me. I mean, when you go into some venue, do you like going to a portal, having to put in your email or having to get out a credit card or having to watch an advertisement and all of that? I mean, nobody likes portals. It's probably the number one complaint for access, right? So what we want to do is we want to eliminate the portal. We want to make the connectivity automatic. And what we found is that if you automate the connectivity with a dominant identity credential, like a Google ID or an Apple ID or an AT&T ID or a Comcast ID, there's some of these IDs are sort of ubiquitous, right? So if you do that, we find that attach rates go from 20-25% to up over 90%. And if you can quadruple your attach and it has an impact on the bottom line for the shopper, then there's a great deal of interest in doing it. So that's just a couple of examples looking at a couple of different verticals on why this is so important, and significant.
Totally. And with regard to these industries, they're also investing heavily in IoT devices, right, and networks, which is a whole different set of challenges. So, is there anything that's being done out there to help these industries, take or tackle wireless IoT challenges that go beyond simply Wi-Fi and cellular?
Yeah, absolutely. And so typically in the cellular domain, what you would do is you would have a device and they would use that SIM. Or on a simple device, they would use something like an eSIM. And an eSIM is basically an encrypted credential. What we typically do in Wi-Fi is we use again, I don't want to go into call flows, but we use .1x and we use EAP. All the typical security mechanisms that you would expect. And we can do different types of authentication against a certificate or against a pre-shared key. The typical kind of things that people are used to using. So just to give you a comparison on what the difference is, we're employees at Cisco. When IT provisions the devices at Cisco, what happens is you log in, and in that login process, they push a encrypted certificate into that device. And then based on that, you can connect to any Cisco network anywhere around the world. Another example of say, what they call a pre-shared encryption key is, say you want to read your email, your Google email, but you want to use a different client. And what you do is it redirects you and you log into Google, say it's Gmail, right? And then Gmail provides you an encrypted key. So now you don't have to log in every time you get your mail because you have an encrypted key right in that application. And now it can just always do mail. So there's multiple different mechanisms. So what we wanted to do to automate this and make it simple is to accommodate the different authentication mechanisms regardless of the type of device. So when we talk about IoT, there's another challenge. Most of the devices that we're talking about for making people productive, for digitizing people, that digital analog interface that we're used to using, it's a phone, it's a tablet, it's a laptop that has a keyboard or a mouse, so you can interact with it. A lot of IoT things don't. No keyboard, they call it headless. So how do you onboard this light bulb, or how do you onboard this sensor, or how do you onboard this tag that you're going to track? And so there's different ways of doing that. Sometimes what you do is you scan in a QR code. Sometimes what you do is the device comes up and it's actually emanating a Bluetooth signal, and you latch onto that Bluetooth signal, and then you exchange the key there. So you might use one wireless technology to onboard another wireless technology. Frankly, it's a little bit complex. And so Cisco's got a program that we're working on right now to really simplify this. What it does is it provides an abstraction layer similar to the days when, if you remember, when we had all these protocols. Now, you don't look as old as me, but
That's why I shaved my beard.
I remember when, yeah, yeah, most of my gray's down here too. Uh, but in the old days, Cisco got famous for building routers, right? And what did we do? We did AppleTalk, we did IPX, we did DECnet, we did TCP/IP, and then TCP/IP became the dominant technology, and the whole world built on top of it. Well, in the world of IoT, that's where we are. You have these different IoT technologies. Some of them are have been out there a little bit longer and legacy, and some of them are newer, like Thread or Matter. And so these run on similar radios. It's called a 15.4 radio out of IEEE, and they run a stack on top of it. Some of them are mesh technologies. But anyway, the point being is that there's a lot of them. And so what we wanted to do is to provide a common northbound interface so that the management, the IT management, or a third-party developer could talk to all these different kinds of IoT things through that single interface. So if you can program to this one interface, if you can do a management platform to this one interface, it doesn't matter if you're talking to Zigbee, if you're talking to Wi-Fi IoT, if you're talking to Bluetooth, if you're talking to Matter, if you're talking to Thread, just to name some of the popular ones, the interface is the same. 3 components: discovery and onboarding, which is what we're talking about. And it's one of the reasons we started this initiative. So how do you onboard it? Just like what we want to do with smart devices, configuration of that device, and then the ability to exchange telemetry. And so that's the program. So IoT is important. It's going to take a little bit longer to get there because I think there's a lot of technologies that are still coming together, but we're working hard on it.
Love it. Sounds really exciting. I want to actually jump back to last year, believe it or not, 2023, for anybody listening, because you were named CTO of the Year by the WBA, which is the Wireless Broadband Association, for your exceptional contributions in advancing technology, establishing standards, enhancing Wi-Fi connectivity for millions of users globally. So, first of all, congratulations on that recognition.
Yeah, thank you. Thank you.
You got it. So, as you look to the future of wireless convergence and the impact of Wi-Fi 7, as a thought leader in the field, what are you excited about? What do you see coming up on the horizon?
So if we continue down that convergence path a little bit, when we developed the OpenRoaming protocol stack and then put it into the standards, and so is now available to the entire industry. But when we developed it, we called it Open Roaming. And unfortunately, sometimes that gets misread to mean open as in not secure. And actually, open roaming is exactly opposite of that. If you do an open roaming connection, it's always secure by definition. In fact, you can't connect without the security. It's one of the things that you get with open roaming. But the idea is that when we say open, is that any IDP or identity provider can play. So think about identity providers. Where does identity exist? Right? Well, you have an identity with your cellular provider, you have an identity with your employer, right? You have an identity probably with Google, you might have an identity with Apple or with Samsung, right? You probably have an identity with Visa, right? You have it. I mean, there's all sorts of identities out there, and some of these identities are considered very secure identities. Like an identity with AT&T, for example, would be very secure because you have a billing relationship with them. They've done a background check, so that would be considered a very secure type of identity. And so when we say open roaming, what we really mean is we're open for that federation to connect things together. We're open to any type of identity provider and any type of access network. Now, the most obvious convergence play is what we call Wi Fi offload. So, in other words, an operator may have trouble penetrating into a building. Maybe they use a lot of glass and there's lead in the glass for the tinting. So, they want to go to the Wi Fi that's in the building for a good, strong signal, right? So, they would go to the Wi Fi that would offload the carrier 5G network, right? Not only would it give a better experience to the end user, but it would actually use the internal spectrum as opposed to the 5G licensed spectrum. So that's a typical use case. But what we really wanted to do was completely open this roaming domain. So when you think about AT&T roaming with the Vodafone or an O2 or these different operators in Europe or these different operators in Asia, I would call that homogeneous roaming. But if you want to be able to roam, say, between an enterprise that's run by an IT department, or a store that's run by an IT department, or an airport that's run by an IT department, right? And a service provider, now you need to be able to cross some of these boundaries. Because what is roaming really? Roaming is really a business relationship. When Verizon roams with Vodafone, that's a business relationship. And when Vodafone connects a Verizon or an AT&T user, then they're billing back to that service provider that you actually paid to have service wherever you go, right? So these are business relationships. Now, if you open this realm of credentials to this realm of access networks, now what we're saying is that roaming can be heterogeneous. That means we can roam using any credential on any access network anywhere. Now that's cool, right? If you can do that, right, now you have all these new business relationships that can be formed. So remember, I was giving that example about the hotel where you might buy the premium service? With this type of roaming relationship, Cisco could say, for my employees' productivity, wherever they go, use the Cisco credential to automatically give them premium service. And then any place that you would walk into, you'd get that premium connectivity, QoS, and security, the same security you would have if you were on the Cisco network, even though you're on a visited network, because you're doing this roam and you're doing this roam with a policy. That's cool. So we're just starting to see this really, sink into the different players, because there's so many potential business relationships that you could do with this, that you're starting to see some spring up in some verticals, and you're starting to see some happen over here. But I think what it's going to do is it's going to produce a world that wherever you go, you're going to be able to get that best type of connectivity. So I would say that's one thing that's happening, is that we are going to automate this type of connectivity. You in the future will not have to be an expert on connectivity. You won't have to know to go to the connection manager. You won't have to know you have to pick a certain SSID. You won't have to know that, oh, I can't go to this one with a lock because I don't have the password. You won't have to know, all these crazy things that we have to know to make this stuff work. You won't have to know how to navigate a portal. And if the portal doesn't work, that you have to go to a web browser, right? And, all of these things that we kind of do to, mess around with this stuff, it'll just happen, and it'll just happen automatically. Now, if that connectivity is happening automatically, now that means that at any one time you can have multiple connections into a device. If you have multiple connections into a device, and say you do go from Wi-Fi and walk outdoors and go to 5G, now you can make that very seamless, right? Or if you're on 5G and if you're going into Wi-Fi, you can make that very seamless. If say you're in a cab and you're going into the airport, I've done this many times. I travel a lot. What happens is that the device sees the Wi-Fi, but it doesn't have access to the internet yet. Why? Because you didn't go to the portal. So it's connected to the Wi-Fi, but you don't have access to anything. So you go to pull up your boarding pass so you can get through security, and what happens? It doesn't work. You don't have access to the internet, right? So that's why that's happening, right? But if you're doing this open roaming type capability and it automatically connects to the Wi-Fi, that's not an issue. Your sessions are always active, they're always secure, and they're always done with the QoS that's associated with the identity that you use. And so we really have to eliminate these portals and get to that next layer.
That was really good, because I mean, really, what it speaks to is what I think we're trying to achieve across the board, in terms of technology for the end user, which is simplified experiences. Making things almost sort of second nature. You're not even worried about the things that you shouldn't have to worry about if you're really just trying to get from point A to point B. So it totally makes sense to me.
Yeah, and look, I'll never forget. I had this experience. I'm the wireless CTO at Cisco, and I'm in the UK. I think I was in bed, right? Not my phone rings. Oh, it's my wife. She's at the airport, and she's like, Matt, I'm at the airport. I said, do you realize what time it is in UK? She goes, it doesn't matter. I go, I'm in the airport. I need to connect to the Wi-Fi because I got to sign up David for soccer. It's due today. Before I get on the plane, I got to get him signed up for soccer. How do I get on the Wi-Fi? And I said, well, you have to go into the connection manager. She's like, what? And I said, well, you go into settings and go into Wi-Fi, and then you got to pick an SSID. And she goes, well, what SSID I pick? Wait, I say, you got to pick one that doesn't have a lock on it. Well, why do I have to pick one without a lock? Just trust me, you have to pick one without a lock on it. So she picks it, right, and still, but the portal didn't work. It didn't redirect correctly, right? And then you got to know that you have to go to. And finally, she just said, "Matt, I'm getting on a plane in 10 minutes. Get me on the network." And my response was, "Turn off your Wi-Fi."
Turn off the Wi-Fi.
She turned off the Wi-Fi. The traffic went to 5G because why? It was automatically connected, right? She got our son registered. Now, this was, I don't know, 15 years ago, but I remember thinking then, we've got to do better. We've got to do better than this, right? So, and we have, right? So now we can automate this process. It's much smoother. It's more secure. We should get a 5G experience when we go into Wi-Fi, and then we should be able to pick the path based on what's giving the best service, and that's what we're doing.
I love that. Couldn't agree more. You mentioned soccer with your son. I actually wanted to segue. This is perfect because I wanted to talk about stuff outside of work for you. So let's talk about when you're not immersed in the work that you do every day and you're looking to relax or have adventure. What are some of the activities or hobbies that you find yourself doing, when you're off work, that is.
Well, so there's a couple of things. So one of the for folks like us, there's always somebody on the phone. There's always another email. There's always another message coming in through WebEx. So for me, it's a little bit about escape. To be honest. And so what I like to do is get out and do a run. It allows me to think. I take my dog. They like to go running out there beside me. In fact, my dog is probably what keeps me consistent, because the dog's with the leash waiting by the door, in the morning to get out there on that run. And there's just something about getting out in the fresh air. I got a place. It's called Bass Lake over here. It's about a mile and a quarter. One time around. You're running around this lake. You can hear the ducks. You can see the turtles. My knees aren't what they used to be. It's a nice soft padded run. There's just something about that allows you to not only run but sort of contemplate some of the things that not only do you need to do, but where do we need to do innovations and things like that. I think what happens these days is that we can spend an entire day jumping at interrupts, and you really need to find a way to get some time that allows you to really think about where you are, where you're going, and what needs to be accomplished. And something about running, the endorphins, you I don't know if you're a runner, but you go a certain distance and you get sort of this runner's euphoria, and then your body becomes very systematic, right? Your breathing synchronizes with your step, and to me, it's just overall a good experience. Besides the fact that I do it for all those reasons, but it keeps you healthy too. So that's
Absolutely. Yeah, totally. I can relate to that. Yeah, I've actually been running indoors on a treadmill for quite a while now, just because, like you, my knees are very temperamental if I'm on hard surfaces. But it really is a combination of that euphoria when you pass a certain distance or a certain time, and of course the health benefits that come with remaining active, particularly as we get older. And I think on that note, that is a perfect way to bookend this conversation. Matt, thank you so much for all of your insight into all things, wireless, Wi-Fi 7, cellular, convergence, things that I really didn't know as much about before this conversation. So I really appreciate your thought leadership and your insight into those topics. And I hope that we can chat again in the future in person.
Yeah, because, I only told you one thing to look forward to in the future. I've got a bunch more. So, it'd be good to talk about some of those other things.
Absolutely. And we will. Thank you so much. And I hope to speak to you again soon.
Thank you. And, great conversation, and looking forward to it.